This video is for educational overview only. Viewers are encouraged to study the topic in detail and continue their academic learning alongside this video. Thanks.
All right, today we're looking at something pretty wild. How you can take a bunch of old smartphones, yeah, e-waste, and forge them into your very own private AI supercomputer that can actually go toe-to-toe with the cloud. So, let's just start with a crazy question. Think about that drawer you have at home, the one filled with old phones and random chargers. What if I told you that inside that mess is the secret to building powerful, private, and unbelievably cheap artificial intelligence? To really get why this is such a huge deal, you have to understand the scale of the problem. In 2022 alone, the world generated 62 million metric tons of electronic waste. And it's only getting worse. That's projected to hit 82 million tons by 2030. And the craziest part, we're only actually recycling about 20% of it. And this puts us in this bizarre, paradoxical situation. On one hand, the demand for AI processing power is just skyrocketing, creating a massive shortage of the high-end chips. And at the exact same time, we are literally drowning in perfectly good, high-tech silicon that we're just treating like garbage. This is where the whole story flips. Because that e-waste, it's not just trash. It's an urban goldmine just packed with computational power waiting to be unlocked. So, who's the hero in all this? It's not some billion-dollar server farm. Nope, it's the old flagship phone from a couple of years back. You know, the one you upgraded from? It is absolutely packed with surprisingly powerful and, more importantly, specialized hardware. And the secret weapon hidden inside that phone is the NPU, the neural processing unit. You can think of it as a dedicated brain just for AI. It's not a generalist like a CPU. It is purpose-built to do one thing and one thing only: run the crazy complex math for AI models and to do it incredibly fast while sipping power. And when you look at the hard data, it is just fascinating. Check out the efficiency here, measured in tera operations per second per watt of power used. A smartphone chip from 2023 is just dramatically more power efficient at AI tasks than the very latest brand new desktop chips. It makes sense, right? Mobile chips were always designed for performance per watt, and for this job, that is its killer advantage. Okay, so this is absolutely crucial. It's all about using the right tool for the job. You see, those giant power-hungry GPUs, they're amazing for training new AI models from scratch. But for just running a model, what we call inference, the NPUs are the undisputed champions. They can be up to 60% faster while using almost half the power. They are absolutely perfect for our recycled supercomputer. So we've identified the gold. Now, how do we actually get it out of the rock? The next challenge is liberating all that processing power from the shiny glass box it's trapped in. Look, turning a consumer gadget into a rock-solid 24/7 server node really happens in two main stages. We have to perform a physical modification on the hardware, and then we need to do a digital jailbreak of the software. First up, the physical part. You obviously can't just leave a phone plugged in forever. That's a serious fire risk. So, the critical step is a battery bypass. This basically involves taking out the battery's little control board, tricking the phone's sensors into thinking the battery is still there and healthy, and then feeding the phone a stable, correct voltage directly from a power supply. And this quote from the DIY community just perfectly explains why that bypass is so critical. A lithium-ion battery that swells up from being constantly charged is, affectionately known as a spicy pillow. And yeah, it's a huge fire hazard, and it's the number one thing you have to get rid of to make a phone a stable server. Okay, once the hardware is safe, we need the digital key to unlock it. And it turns out, a recently discovered software exploit for Qualcomm chips is that key. It lets us completely bypass the manufacturer's software locks, rip out all the unnecessary stuff, and get total control, what we call root access, over the device's full power. So now we have one unlocked, super efficient AI node. That's cool. But the real magic, the part that turns this into a supercomputer, happens when you connect a whole bunch of them together. This is how we forge the hive mind. The brain of this whole operation is an open source framework called EXO. It's the software that lets this whole swarm of individual phone nodes find each other on a network and act as one single unified AI cluster. And EXO's architecture is its secret sauce. See, traditional systems have a master computer telling everyone else what to do, which creates a huge bottleneck. EXO uses a peer-to-peer mesh where every phone is equal. That means as you add more phones, the whole system just gets faster, and the communication delay drops from milliseconds down to microseconds. It's a game changer. So what does this actually let you do? Well, let's just break down the math. A really big 70 billion parameter language model needs about 40 gigabytes of memory to run. Your single phone, it's only got about 12. But with XO, you can shard it. Basically, you split the model up across a cluster of 4 phones. Their memory gets pulled together and boom, you've got 48 gigs, which is more than enough to run the whole massive thing. Okay, so we've hacked the hardware, we've orchestrated the software, now for the payoff. Let's take a look at what this homegrown sovereign supercomputer can really do. The performance is it's staggering, especially when you look at responsiveness. That time to first token, which is how fast the AI starts responding to you, is under 20 milliseconds. Compare that to half a second or even more for a cloud service. For something like a voice assistant, that difference is everything. Oh, and notice the data fees? Yeah, 0. And honestly, this chart right here, this is the most compelling argument of all, the cost. To process 1 million tokens of information, a big commercial API could cost you over $2.50. Renting a cloud GPU is around 89 cents. The recycled smartphone cluster? 11 cents. That is not a typo. It is more than 18 times cheaper than the big guys. This whole setup also allows for something called a dark node. This is an AI cluster that is completely air-gapped, meaning it has absolutely no connection to the internet. For anyone dealing with sensitive medical data or top-secret R&D, this is the holy grail. It's complete data privacy and sovereignty. You and only you are in control. So you see, this is so much bigger than just a cool DIY project. It really represents a fundamental shift in how we think about computer power. It's all part of a much larger, and I think much more important, decentralized compute movement. And that really brings us to this powerful idea. We have to stop thinking about our old phones as disposable junk. Their useful life isn't over just because a new model came out. We are entering a new era where these incredible devices can be reborn as nodes in a personal, private, and powerful computing engine that we control. So I'll just leave you with this question to chew on. That junk drawer, that box in your closet, that's your own personal urban mine. So what incredible potential, what latent intelligence is just locked away inside it, waiting for you to unleash it?